Hello, pre-calc students. Mrs. Fallon here. We are on video 1 of Unit 1. And so what we're going to be talking about today is sections 1.4 and 1.5 out of our textbook. So if you have an ebook or if you're following along, that's kind of the sections that we're going to be kind of talking about in this video. All right, so to get started, what we're going to be talking about is just kind of a review of how do we test to determine whether a relation is a function. And so what I gave you on this front sheet is a few different ways in which we're going to represent relations. So a relationship is really just kind of like a relationship between x and y. So this is just what we call a set of ordered pairs, right? So here's like a few different points. We're going to do a graph, we're going to do a table. I don't know if you remember what a mapping is, but we're going to talk a little bit about that. And then kind of talk a little bit about how we can determine from an equation whether or not something is a function. So when we determine something as a function, there are a couple rules. If we're looking at a set of ordered pairs, kind of the shortcut way of what, at least how I look at it, is we look at our x values. And so what I'm looking for here is that my x values, or my x's, cannot repeat. And so the reason why is because when we have, what makes something a function is that there's every x value has to have a unique y value. So what that means is that there can never be like two points that have the same x value that produce different y values. So for example, on this one, the easiest way to find whether or not a set of ordered pairs is a function is to look at all of your x's. And again, you really just care about your x values, not your y values. And you're looking to see that the x's don't repeat. So I have 3, I have -5, I have 0, and I have 3. Clearly, we have 2 points that have the same x value. So that means when I input 3, I could get 2 different kinds of answers. And that's the problem with this one. That makes this not a function. So we would say this is not a function. And so that's how you can tell from a set of ordered pairs. A graphing, let's just add some points. And it's not super imperative that you have these in the exact same spot as me, but I'm just going to add a bunch of points here. I'm actually not even going to connect them. I'm just going to add a bunch of dots. And so if you're given a graph, whether the graph looks like this, like a finite graph, in other words, there are a set number of points, or whether it's more your typical graph where you have like a graph of a parabola or a cubic or a quartic or whatever it is. What you're looking for here, if it passes the vertical line test. So if you remember, a vertical line test, and you probably have heard that before, is where you can take, like on a graph, if you can draw a vertical line and it only passes through one point, then it passes the vertical line test. So in most of these, I can draw a vertical line that only passes through one point, right? But in this scenario right here, if I draw that vertical line right here, it's going to intersect this graph, because all these little dots are my graph, it's going to hit in 2 points. So this fails the vertical line test. So this fails the vertical line test, and that's how we abbreviate it, so VLT, vertical line test, which means this is not a function. So again, similarly as how we did with the ordered pairs, if I were to plot these on a graph, this would fail the vertical line test. That means I have 2 points that have the same x value. So this is just one way of looking at it and another way of looking at it. Next, we can look at a table. And you've all seen tables before. So even if we look at, something pretty basic, I'm just going to pick a few. It doesn't really matter what my numbers are here. What you're looking at for a table is similarly, you're looking to see, kind of like with a set of ordered pairs, because that's really what a table is a set of ordered pairs. You're looking to see that the x's don't repeat. In other words, if I graphed these, would the graph of these points pass the vertical line test? And so what you're going to notice is, again, look at your x's. So all of my x values are unique, which means when I plug in a specific value for x, I get a specific value for y. If I plug in 1, I get 5. If I plug in 2, I get -1. If I plug in 3, I get 5. So you can have your y's repeat. Notice that. It's just that, so I can have two different inputs, that's what we call our x values, right? I can have two different inputs that produce the same output or y value. I just can't have it the other way around. So in other words, I can't have two different outputs that produce the same input. So this one is a function. And so why we're looking at this is, again, it would pass the vertical line test if we were to actually graph this on a grid. And kind of the cheap way of looking at this is my x's don't repeat, so I kind of know that it's automatically going to be a function. All right, a mapping. I don't know if you remember mappings, but they're like these little ovals. One represents x and one represents y. And I don't know, I'm just going to pick some numbers to put in here. Okay, notice that I put the numbers, I'm just putting those numbers in any kind of random order. And then what you will see is you will see like arrows drawn. So the number of arrows that are drawn. So I don't know if you remember this. I think you probably did this in Algebra 1. So it's probably been a little bit, maybe in Algebra 2, I'm not really sure. So how this mapping works is, again, it's kind of like a table. I mean, really, what it is you can list your ordered pairs. So this says that when I have an input or an x value of 0, I have an output of -1. So I can list that as a set of pairs. When I have an input of 3, I get an output of 5. Because there are two arrows, that also means when I have an input of 3, I have an output of 4. And an input of 5 gives me an output of 5. So looking at it as a set of ordered pairs, you will notice that they have two of the same x values, which makes this not a function. So rather than having to write out all of those points, not that that was extremely tedious or anything, but the kind of the shortcut way, if you're looking at a mapping, is if you have more than one arrow coming from one of your x's. So see how in this number 3, I have an arrow that points to 5 and then an arrow that points to 4. What that indicates is that I'm going to have the same x value that goes to two different y values. And so then that causes me not to have a function. All right, how we can tell if it's algebraically is basically if I solve my equation for y, I get a unique x. So let's take this equation and solve it for y. So I'm going to subtract x to the 4th from both sides. And again, you probably did this in Algebra 2, but let's try to get rid of this y to the 4th. So to get rid of something to the 4th power, you take the 4th root. Anytime you 4th root or square root or 6th root, so any even root on both sides of an equal sign, you must put a plus or minus. That's why anytime you do like the quadratic formula, it's the plus or minus in there. Anytime you square root, there's a plus or minus. It's not just for square roots, it's actually any even root. So this is not a function. Write it down. So this is not a function because when I plug in a value for x, I could get the same x value could produce two different y values. So for example, because of this plus or minus, so the issue here is because of this plus or minus, I'm going to get two different, like I could have the same x value produce two different outputs or two different y values. Now, if I had an equation, let's say I had, y cubed equals 16 minus x, and I cube rooted both sides of my equation. Now, if you remember anything about odd roots, you do not put a plus or minus. This would have to give me a unique, like for every value, I get a unique y value. So this would be a function. So basically how you can tell algebraically if something's a function is this whole plus or minus. So if you're 4th rooting both sides, if you're 2nd rooting sides, if you're 6th rooting, if you don't have a plus or minus, then you're going to get only one possible answer, which then means that it's going to be a function. All right, so that was kind of an overview of 1.4. Let's kind of move forward to 1.5. So in 1.5, we're really kind of looking at graphs of functions. And so I gave you this kind of this polynomial looking graph. And what we're looking at here is just finding the domain and range. So just to refresh your memory, if you remember, domain means x values. And then your range means your y values. So what we want to look at, and I'm going to write this what we call an interval notation. When you write your domain and range, what you're looking for is your lowest, comma, highest. So lowest to highest x values. So domain is x. So looking at my graph, here's my x-axis, right? This one. Right? So my lowest x value appears to be -3, right? That's the lowest x value I'm going to get. My highest x value appears to be 1. So here's my lowest x value, here's my highest x value. So how we would write that is we would say my lowest x value is -3, my highest x value is 1, and now here comes into play where we're going to have like the parentheses versus the brackets. I'm going to put a parenthesis here and a bracket here. And the reason why, let me tell you, is because at -3 we have an open circle. So the parenthesis means we don't include -3. And how you will see that on a graph, off the paper here, is it will have an open circle. Kind of like those inequalities where you shade in the circle and you don't, right? So this one had an open circle at -3, which means we don't include -3, which is why I put the parentheses. If you notice at 1, there's a closed circle. So that means we include this value. So we include 1 in our number set. And then how you can tell which one, kind of how you can tell from the graph, is that it would have a closed circle. So this is what we call interval notation, this notation right here. So it's always your lowest, comma, your highest, and then either parenthesis versus bracket, depending on if you include the number or don't include the number. Same thing goes for y's. Range is your y's, so my lowest y value, so again, now we're looking at this axis, the lowest y value appears to be -4. My highest y value appears to be 0. So lowest to highest. The -4, is there a closed circle? Do we, there is, so I'm going to include it, which means I'm going to use a bracket. And then the 0, so my highest y value, there's an open circle here, but it appears, unless we know otherwise, which I'm going to assume that this is a closed circle at 0, which means it does exist there because at this point there is a y value of 0. So because there's a closed circle at 0, we would have to put a bracket there, not a parenthesis. So again, when there's kind of one of each, kind of the closed circle trumps or overpowers the open circle because you're looking to see, is there a value at that particular point? And the answer is yes. So lowest to highest, lowest y value to highest y value. All right, next example, find the zeros of the function algebraically. So this is a good question. I want us to all know what the word zeros mean. When I ask you for the zeros of a function, I'm asking you to find your x-intercepts. Algebraically, what that means is that you're going to plug in 0, so plug 0 in for y. That's what that means. So when you're asked to find a 0, you're finding your x-intercepts, or in other words, you're plugging 0 in for y. You are solving an equation, okay? So you've done this in various forms all throughout Algebra 2, and Algebra 1 for that matter. So you are solving this equation. This happens to be a quadratic, okay? If you remember how to solve quadratics, which hopefully you do, you might remember this is a trinomial, which means we could either use one of two methods to solve. We could factor it, which is my favorite, or we could use quadratic formula. So I'm going to go ahead and factor this one. So how I factor this, because it's a trinomial, I'm going to look for numbers that multiply together, or values that multiply together to give me 3x squared. So that's 3x and x. There's only one set of numbers that multiplies together to give me 7, and that's 1 and 7. I know it has to be here and here, because if I put the 7 in this spot and I foiled the out, I would have like 21x. And I know I'm not going to be able to get a middle term of 4x if I have a 21x over here. So I put the 7 here and I put the 1 here. And basically what you're doing is, I always use this like as guess and check. So I say 3x times x is 3x squared. 3x times 1 is 3x. 7 times x is 7x. In order for this to give me a positive 4x, I need this to be a negative 3x and a positive 7x. So see how that works? Now if I FOIL this out, I would get a middle term of 4x. And then if you keep foiling, 7 times negative 1, I get negative 7. All right, we're not quite done. We did ask to find the zeros. In other words, what that means is you have to actually solve. So take each of your factors and set it equal to 0. And then solve for x. And then over here. So these are the zeros of my function. The last example is really just kind of, we're going to kind of walk through this one. It's not really an example per se. So what I want to show you is this idea of increasing, constant, or decreasing intervals. And so an increasing interval is basically where it has a positive slope. A constant interval, which is this up here, has a slope that equals 0. And then a decreasing has a negative slope. So if we look at these, what you can tell is that you going from here to here is an increasing. From here to here is constant. From here to here is decreasing. And so what you're looking at is you're looking at the x values only. So when you name like an interval in which something is increasing, you would say this is from negative 5 to positive 1. So because there's two things going on here at positive 1, like in other words, positive 1 is when it ends that we're increasing, but it starts where we're constant, we're going to use a parenthesis there because there's like two things going on. So I would say it's increasing from negative 5 to 1. I would say it's constant from 1 to 3. And because there's kind of multiple things going on at both of those, notice that I put parentheses in both. And then from 3 to 5, we've got, the parenthesis around the 3, but the 5, we are looking at a closed dot, I guess we'll say. And so when you name these, you're looking at the intervals and you are making adjustments based on whether or not it has a positive slope, a zero slope, or a negative slope. All right, that's it for video number 1. Hopefully you took some notes. Come to class with any questions. We'll be going over the rest of your packet, like the rest of the stuff that's in here, in class probably the next day. All right, bye for now.